Yes, today we're gonna be learning Rust. Yes, really. I'm fully going in the pipeline direction of being a trans girl, using Rust, wearing pink striped thigh highs, which I recently bought, and stuff like that, and then eventually switching to Arch Linux and nothing else, or rather, nothing less. So, as usual, when I start learning something, where I go to use YouTube, I try to watch a video on it. But then I remembered that No Boilerplate, amazing channel by the way. Um, yeah, yeah, for real. Like I'm actually starting to learn Rust today. I've been wanting to for a long ass time, but my I guess excuse was yes, programming socks. They're so nice. I don't envy men. It's not like they can't wear thigh highs, but society kind of forces them not to, and I find that sad because thigh highs are so nice to wear. Maybe that's just me, but my legs are constantly cold, and in them, that's no longer an issue. Yes, so I was watching a YouTube video actually on how to learn Rust, and the video is suspiciously just 2 hours long. And I was like, oh, okay, I guess I'll learn it this way. So that's why we have this directory with a bunch of stuff already in it. But then I recognized that if I watch a video, I'm not going to be able to turn it into stream content. So I want to start with GitHub repo delete Rust Rust learning, and then I remove this directory and create another one, GitHub repo create clone, and it's now going to be public, so in case you're interested in whatever the fuck I'm doing, and in case I commit it, then you can go look at it. So a new public directory called Rust Learning. And let's rename it to just learning. So when I try to go to the directory by FZF, basically, let me show you. I do Rust learning, and here I am, rather than being Rust learning, you know? Let's go there. So I already know how to create a project. It's cargo new. I have no idea what the Rust syntax looks like. It's a mix of functional stuff, like Haskell, and your usual programming language, like OOP. I've seen a bit, and it's quite a bit more loaded, but I think for a good reason, and I'll guess we'll learn that. Can I do something like this? Huh. Oh, that's interesting. I can just cargo init. That's new. To create it in this place. That's so interesting. Oh, by the way, what I find interesting is when you run cargo new, it automatically makes that repository, or that directory, a Git repository, like automatically. Basically, it expects you to be using Git, which is really cool. So, I guess we just GCR as the first commit. Yeah, we GCR, I'm pretty sure. Yeah. So we git add everything, make a first commit, and bind it to the origin, meaning the remote branch. Let's open it in VS Code. I already have everything installed. And that everything is, don't worry, it's not that much. You just install the where is it, Rust Analyzer, and you install, well, Rust. Unfortunately, there's no like option to use Rust on my WSL. So what I have to do is install Rust on Windows as well. And not only do I have to do that, I also have to install Visual Studio because it contains a bunch of stuff that Rust uses. So basically, using Rust on Windows is already a horrible experience, which I do not recommend. So if you're using Linux straight up, then like, here you go. So we have this function main, which I quite like, the fact that Rust still has the main function that is executed. Yeah, it's really not a good time. Like, to get up and started with Rust, well, technically you don't need to be using like this extension. And if you decide to not, or if you decide to ignore its errors this is going to throw at you, then yeah, you can just, what, really? Why can I not middle click to close this? That's ridiculous. Yeah, so if you decide to not use the extension, which, let's be fair, will help you out a lot, you can still just do this from the terminal, and I intend to, at the very least, run Rust from the terminal, so from the WSL side, using Cargo that is installed on my Linux system, which is way easier. You just like sudo apt install, and I imagine Cargo or something of that nature. Not sure, but something along those lines. Or maybe you just go to Rust up and it has like a cute command. Yeah, right, that's the thing. So yeah, and in Linux, that's all you have to do. You just run that command, boom, you have Cargo installed, that's it. On Windows, you have to go through hoops. So let's go back to main. Now, I wonder, first of all, preview editor. You see that the previous thing, if I open another file, it will get replaced. Once I make a change or double click on the file, then it will no longer be a preview editor, and it will stay. Now, I wonder if there is a command that I can set a hotkey to make a preview editor an editor that actually stays. You could say that I could instead just not use preview editors, but say I'm trying out extensions, looking at them, and by the time I've looked through a few, I have like 20 tabs open because they don't replace themselves, and that's pretty annoying. Applies to other files as well that I really only need to look into once. So I want to check out if I have anything that will help me out with that. Reset choice. Let's actually make that a bit bigger. Okay. Focus. No. Previous primary sidebar view. Interesting. Preview declaration. Yes, they are indeed called preview editors. Right? Yeah. So I imagine there is a command. It would be weird if it was hard-coded into double-clicking or a change. I think that would be kind of dumb. There, I also open a billion extension tabs to go back to, though. Yeah. I mean, to be fair, there is a command called something like close all the editors, meaning tabs, to the right of the current one. So if you say you have some file open and then you check out a million extensions, you go back to that file you had opened and run the command, let's actually look for it, close editors to the right. That's interesting that the to the right thing is not here, but here we have close editors to the left in group. So we can use close editors to the right in group to close all of that extension tabs. I know, right? And we also have, yeah, close all editors in group, and then close all editors meaning all the groups. Pretty cool. Close editors in other groups meaning leave only the current group basically working. But the more important, or rather more useful one, is close other editors in group. So say you had only one file opened, you check out a billion extensions, you go back to that file, run this command, and only that file will stay. This is also useful if you have non-autosave. The only keybind for VS Code to remember is Ctrl-K and F to get out of a folder. To get out of a folder? What do you mean by that? Also, I don't really remember hotkeys. More than likely, I remake them. For something like NeoVim, I'll usually try to remember, and if it's completely ridiculous, then I'll maybe change it. But for VS Code, I'm very fast in actually changing stuff. Okay, so it seems like there is no command that I'm looking for, which is surprising. Well. Turns out I already had the functionality that I was looking for. So first of all, let me toggle screencast mode so you can see. And let's reopen this. It's currently a preview editor. When I press capital U, that saves the file, but before doing that, it trims trailing white space. So I'm pressing capital U, and it's no longer a preview editor. So I already have this functionality, turns out. Also works to get out of repos. What do you mean by get out? What do you mean by get out? Okay, so let's go and car. Car ends up being cargo run, so it compiles the project and runs it. So here we have hello world. And one thing that I immediately expected to work, and it did, is it was print line and then exclamation mark, which means that this is a macro. So I imagined that print line would print a line, and print would just basically console write without appending a new line at the end. So once it compiles, you'll see that I was correct, because we have this symbol that means there is a new line missing here. So immediately I could very easily guess how a thing worked without even needing to go read the docs. Immediately, like, a very good point to rest. You know when the files are shown on the side? It means you opened the directory. What do you mean? You mean like this? Or rather, hold up, this? So by get out of a folder, you probably mean do this, right? Or do you mean like closing it? Okay, so what are the changes that I have made that are cargo lock and main rs. What are the commits that I have made? Only the first commit. Means it's complicated, is it? Okay. Let's look at the git diff. Oh, that's the only thing that changed. Okay. And the other is cargo lock, which automatically appears once you compile a project. The git ignore is already there, by the way. When you use cargo new, the git ignore is automatically created, which is really cool. So nothing really that I need to commit. Good to know. Good to know. What can I do? Inline macro. Create IO print, then create format args. Oh, how interesting. Syntax error. Expected expression. That's so interesting. Well, I guess we'll come to know what that actually means in the future. So, the way that I'm going to be learning Rust is in the way that No Boilerplate explained in his video on how to learn Rust. So, I'm gonna start with reading the book, the Rust book. I'm not gonna spend too much time on anything really. I'm just gonna, as he said, run all the words through my ICE compiler so I know that they're there, and basically I know what I'll need to know before I learn it, you know? So I'm gonna start with reading the entire fucking book. Yeah. Yeah, like, that's kinda a lot, but yeah, the Rust book. I should probably just add all of these links in the description of the stream, so everyone who's interested can also learn Rust. But what I really recommend you do is watch No Boilerplate's video on this. It's most likely his most popular one, or at least I imagine so. He explains really well how to properly learn Rust. So yeah, I recommend that, most importantly. So, I guess let's start. This is going to be like, I imagine multiple streams of a docs reading session. The Rust programming language. This version of the text assumes that you're using blah. See the installation? Yeah. The HTML format is available and offline with installation of Rust made with Rust up. That's pretty cool. The fact that you can do Rust up docs book, and that will open a file that I imagine is made like temporarily, if not, so you can access the book, I imagine, explaining pretty much everything, even if you're offline, which is really cool. So I want to go to my config.fish and add an abbreviation for that. So let's go to cargo. So we have cargo, and this is Rust up, so RU. Is that anything? No, not yet. So will be Rust up, abra, Rust up docs, Good. Okay, that's also nothing. Rest up. Docs. The URL looks like it's it's booting a local server to host the site. Most likely, yeah. That's true. Interesting that it does host it from WSL. Like, it recognizes that I'm running WSL. And actually, when I was installing Rust, it immediately said, "Oh, I see that you're using WSL." And I was like, fuck, holy shit, how do you know? Files usually look like file blah blah blah. Yeah, you're correct, but I guess I don't open files in the browser too often, so I don't quite, like, remember, I guess. Let's QD, and also I should toggle screencast mode here, just so you know. Rudb. And that's also nothing, that's perfect. Buck. Not quite sure if I'm going to be needing to do that, but in case that I do, going to be pretty useful. Same, yeah. Okay, let's go back. Where were we? Here. So now I know that I have access to the book even if I'm offline, which is really great. I imagine most programming languages give that, right? But on the other hand, I've looked at the docs of Python once, meaning I do not want to look at them again. They're so ugly, and while this website isn't particularly fancy, it does look palatable and nice to look at overall. And actually, let's make it a bit bigger. Ooh, I love that, actually. Wow. Yeah, that's actually quite a bit better. Yeah, so I love this fact that if I want to, I can just do the file, but I'm going to be using the online version so I can go through things and then save the link in my, where was it? Regel in this file. So when I start out, it's just the link to the book, but then it will be more specific to where I ended off, you know? Anti-Python sites are better than Python docs. I feel like, oh, anti-Python. Yes, absolutely. Like, even pro-Python sites are better than Python docs. Fucking HK docs are miles better than Python. But I did hear that generally docs are not that good, and HK is kind of surprising with how good the docs are. Which is, how do I say this? Disappointing? Like, really? A language like HK has better docs than most? That's disappointing. Okay, so let's continue. Several community, in fucking paperback. Wow, that's cool. That we'll actually get to. So the way that no boilerplate, and it would be really cool if you joined the stream. The way he said to learn, I got spoiled by UScript docs Lamau. Are they good? That language doesn't sound like it would be, first of all, good at all, and second of all, have good docs. It sounds suspicious. I want to play a sound effect, but I don't know if you're gonna hear it. Yeah, here you go. Okay, sounds suspicious, but I guess it's only fair after scripting in batch in PowerShell for a while. You're just crazy, for real. Like, even regular shell scripting. Why is there a tractor outside, bro? Its docs are way too good for its own good. Having good docs for a language is so big. If you can figure out how to fix an issue while you're offline, that's such a good language. Well, not the language, the docs, I guess. So for the hotkey, there is an offline file. You can just open it and like here you go. So when I was in the train like a year ago, I think, more or less. What are you writing? Nothing yet. I'm learning Rust first, but my eventual idea, I think it's pretty cool. So currently what I have, it's written in a hotkey. I can type in something like interactive. It searches, god damn! Die! Another truck? Seriously? Don't fucking pull out the third. So, I just searched for my notes, and only one note's title matched. When I open it, I can see it, and it's automatically in my clipboard, as you can see by me showing you my clipboard. So I want to rewrite that in Rust. Essentially, my idea is rewriting my entire project in Rust, and after I do, I'll surely switch to Linux, because I'll have all the tools that I am so used to. It's up to you for your HK vids, but I started learning Rust one. Oh wow, that's actually so like convenient, I guess. That's really cool. Like, I can only imagine I'm going to be making Rust videos, so that's quite nice. Fuck yeah. So my idea right now will be to have like a bunch of streams where I'm learning Rust. So yeah, and my first project of any importance will be this notes thing, where I'll be able to create notes and then search for them, but in the terminal, meaning most of my things will just end up being in the terminal. So yeah. Oh Jesus. Right, what I was talking about, boilerplate, or rather the non-existence of it, told to first read the entire book kinda fast, not really looking into anything, and then read it again, but this cool version, and do Rustlings at the same time, and then Rust by example, and also understanding Rust futures, which is funny. I'm pretty sure that's a mistype, by going way too deep. So a combination of all of this. So let's start. Imagine it just starts out, so to access variables, you need to put a $sign before the variable. Imagine. No worries. At least I'm having fun. A part of streaming is that you get to talk with people, share your experience with them, and hear their experience, and that's amazing. Oh wow, that's a lot. Okay, that's probably important still, right? It wasn't always so clear, but the Rust programming language is fundamentally about empowerment. Let's go, fuck yeah. Features are how you do multiprocessing. Oh. Multiprocessing kinda meaning multi-threading, I imagine? Or is that a completely different thing? I thought it was like an overall document about discovering all the features by going way too deep into them, but it's like more advanced, I guess. Okay. No matter what kind of code you're writing now, Rust empowers you to reach farther, to program with confidence in a wider variety of domains than you did before. I can only imagine that's true. Auto hotkey is pretty limiting. And mood, you know, because you use V1. I use V2 and it's incredibly better, and even still, I'm constantly limited. You can do threading in 3 different ways: async, process, and 2 different types of threads. Interesting. Huh. I've never done multiprocessing or other multi-threading. Never really needed to. But in my noder, I feel like it would be pretty cool to use it. Because I like fuzzy search my notes, a feature that I don't have yet, another hotkey. Why are there like a million tractors outside? Yeah, it's literally a tractor. What is it doing in the city? I don't get it. So, yeah. You should learn Python first. Fuck no. Fuck no, I hate Python. Fuck no. Yeah, fuck yeah. I agree, Mood. Fuck Python. I hate it. It's so, like... bleh. It's just disgusting. I don't have, like, a good valid point as to why I think that way. I just don't like it. It's, it looks ugly. It's way too different, but not in a good way. Like, say the simple decision of using indentation instead of brackets. Like, why? Every single programmer is already used to brackets. By changing that decision and not using them, you're making it more difficult. And those kind of things are all over the place in Python. Fuck that shit. If you're coming from HK with no object-oriented experience, it will be a lot tougher. I have some object-oriented experience, actually. I use C# as well. And that was actually what I was going towards. I am also constantly limited by C# in how Microsofty it is. Which I heard is similar to Java, but Java is even worse. Well, it's just better to, say, learn a high-level OOP language. Yeah, C#, for example. But why I don't like it is how huge it is, you know? It's like a whole entire thing for something even very simple. It's, what's the word I'm looking for? I guess grotesque. It's, too huge, like a horse dildo. And it's not very nice. So you have the option of the hotkey, which is like very small in the way that you feel it, but obviously it's very limited. And error handling is just horrible, especially on V1. And you have C#, which is much better, but now it's huge. Rust, by what I know about it, is like not limited, even less limited than C#, obviously. But it's not as Microsofty, I guess. I said what I said. So I do have some OOP experience. I think it's like way overdue for me to be learning Rust, to be fair. Take, for example, systems level work that deals with low-level details of memory management, data representation, and concurrency. Traditionally, this realm of programming is seen as arcane. True, accessible only to a select few who have devoted the necessary years learning to avoid its infamous pitfalls, and even those who practice it do so with caution, lest their code be open to exploits, crashes, or corruption. C# is pretty good performance-wise, yeah, but I agree it's very verbose, same as Java. I think C# is better than Java, or at least that's the opinion I've heard all over the place. I don't really intend to touch Java like ever. But yeah. Another thing which actually matters to me like incredibly much, the way that I'm used to writing blocks, say an if statement, the hotkey, but in reality in most of, pretty much in any language, in most languages, You do if expression and then brackets. In C#, you're kind of expected to do it like this, which I find incredibly ugly. You can argue that, oh, you can like change the setting and so on, but I try my best to follow the best practices of a language, which is why if I make an interface in C#, obviously I'm going to put a capital I before it, because following the best practices, even if they're not particularly good. Well, Rust is not insane, so obviously it will have this by default, which is nice. And also in C#, and that I imagine is the case for most languages, is the you have to wrap it in brackets, and AutoHotkey you don't have to. The way expressions work in AutoHotkey v2 is actually pretty robust. I like it. So I wonder if I'll need to do that in Rust, like wrap it in brackets or not. I imagine yes, and I imagine it has a good reason to. But yeah, this is one of the examples for why C# feels huge, like a horse dildo. There are other examples, which I can't really give you at the top of my head, but yeah, it does feel huge. The company I work with focuses on both. Huh, interesting. Why not just one? I heard that, yeah, I've heard this sentence many times. C# is Microsoft Java. So like, why not just one? I'm probably like very ignorant on that point, which is why I don't know. I like how it is actually performant at scale. I'm in DevOps. Oh, that's interesting. That's great. Yeah, C# is like a pretty fast language, as far as I know. Like, not just fast enough, but like very fast. It obviously has competitors, and competitors that overrun it like way better, like Rust or C. But yeah, it's pretty good, I guess. Stop with the horse. I will not. Okay, I recently bought a dildo, and I don't have the conversion on me, but it's 18 centimeters, and that's so huge. And it was the smallest one in the shop. I don't get how I'm supposed to fit more inside of me. I guess I'm inexperienced. Because we just acquire companies. Ah, I see. Interesting. A part of my fear in getting a job is that I'll have to use a terrible tech stack. Like, I start a job and they're like, okay, use PHP. Because a surprising amount of Russian companies is in PHP. Like VK, the, I think, largest social network in Russia, written in PHP. And like, damn. Like, really? A language that uses percent signs before variables? Like that? Are you sure? And you write the largest, let's not forget, social network in Russia with this? Are you sure? Very on brand. Axel Wilder screen. Yeah. Incredibly. God. You know what? I hate, matter of fact, I despise the sun. Who created the sun? Fuck him. Honestly, fuck him. I dislike the sun. It just, no matter how many times I move, the sun just always appears on my side. Which you'll probably hear and you'll be like, oh, that's cute. And I agree, if it wasn't so fucking annoying. Like, I'm sitting trying to enjoy the slight, keyword slight, sunlight from the outside, and now suddenly the sun is blazing into my eyes, so I have to close the curtain, and now it's going to be hotter next to it because it's being, like, lit on fire by the sun, and it's just not a good experience. I guess the sun went away. Okay, yeah, that's better. PHP is easy, that's why. Easy languages are a trap, I feel like. Which is like part of my thing about Python. It looks easy, but then when you have to do some hyper-specific things, that easiness ends up being your downfall. When with something more difficult, at first, you actually get more help in the important things. Yeah, I mean, it was very old, so for that, like, I understand. I'm more so surprised when things aren't rewritten when they, I feel like, should be. Have you heard about the Mojo programming language? Yeah, recently, Fireship made a video on it, I'm pretty sure, that I still haven't watched, called something like Mojo, the better Python. But, like, how do I say this? Okay, let me think of a metaphor. Okay, that's a good enough metaphor, I guess. Install V2. It's the better auto hotkey to a systems programmer. Like, it's still fucking auto hotkey. Isn't it just better to use a better language? Trying to improve something that is inherently not, I guess, like, for me, not what I'm looking for at all, I don't see any point. Now, if you're a Python programmer that uses the advantages of the language to their best, Mojo surely sounds like an interesting project, right? But not for me. That's not really what I'm looking for. I'm looking for a language that is strict, and yeah, I'm looking for a language that will top me sexually. I don't want to be the top when I'm programming. I want to be the bottom. And Rust, I feel like, will provide me that experience. Python, not as much. Watch the interview with Chris Latner and Lex Fridman. Okay, I'll check it out. It might have actually been... Can I even switch accounts? I think so. Yeah, I can leave. Okay, let's check out if I have it in my podcasts playlist. What? Oh, lol. Podcasts. So you say Chris Latner, Lex Fridman, Chris Latner. Round 3? Jesus. Okay, I'll add this once the button... Oh, it doesn't appear. Cool. Said Python's indentation is superior. Because in any company you will still parse the code for formatting. Said Python's indentation is superior because in any company you will still parse the code for formatting. Well, the thing is, in bracketed languages, even if someone is shit at formatting, which I'm not already. Like, I format my codes pretty much perfectly always. But those who don't, they can just use format, document, and trust it. With Python, that indentation, meaning also formatting, is now a part of logic. And if something is formatted incorrectly, well, fuck. In other languages, if something is formatted incorrectly, you can still figure it out by the brackets. So I just straight up disagree that it's superior. Maybe eventually our tools will be so incredible where that's viable. But then, let me show something. What about the Vim users? I won't be able to do this without brackets. I mean, sure, I can do something like this for delete inside of indent, but it's far more limited. I think we're at a point where we're just removing features rather than making a better experience with something like that. Indentation is whatever. Mojo mainly keeps the same syntax, right? Just a billion times faster. And really? It's that much faster? God damn. Mojo keeps the syntax but adds types. Okay, that's actually big. Tractor. Okay, he's gonna be the recurring character on this stream. Python has kinda had types for 4 years. Not really. He had type annotations which weren't checked by the interpreter. It was for external linters. So, keyword kinda, because not really. There's a clip regarding the indentation. Personal indentation is easier to write, but more annoying to read. You mean like in Python? I just write a bunch of comments when I'm using an indentation-based language. See, I try to not write comments. I follow the general rule of if you feel like you need to make a comment, an exception is this, like an explanation of a method, basically JS doc. So this is an exception. I feel like you should be doing this like always. But the comments in code, if I feel like I need to make one, I should write better code rather than rely on comments. So yeah, if you mess up a brace in Java, you're in for a logic problem. Like if you forget one somewhere. Yeah, but then the linter just, let me show you. Like, here it is. Like, it's highlighted in red and it's not the correct color. You'll see this immediately. When with indentation, this is now not in this block, and you have to figure it out. That's the thing, like, helping your linter do the things. When in Python, it's more up to you to figure that logic out. You're making yourself, you're using a language that helps you less. Which is why I'm so interested in Rust. Because it's so strict, it will also help me the most. You mean on Mojo? No, I don't mean removing features in Mojo. I mean using indentation for logic, for blocks, that I think is removing features. In terms of Mojo, I don't know. I haven't watched the video yet. And so does Numba. What is Numba? NumPy has pure types, and so does Numba. Oh, that's actually good. That's good. Numba compiles Python jet. Yeah, I never find problems with brackets languages. Exactly, yeah. Like, they immediately scream at you. And I've disliked linters for a long time because for another long time, AutoHotkey didn't have a linter. Now that I use one, it's actually, yeah, and the, I'm meeting my words, I guess. Oh, here it is. Easier to figure out, basically, than with indentation. I agree with your point about it being hard to figure out. Oh, that's great. If there's one thing about Python I don't like is that, the observability is very bad. Yeah, which is why, like, I disagree. Like, the creator of the language, forget his name, of Python, has said that that move was to help beginners, like, write code without knowing how to. I see the point, but I do still disagree that if you help beginners at their expense, you get AutoHotkey v1, where you are allowed, like, you don't get an error if you try to use a variable that you haven't yet defined. You can easily use unset variables. Okay, cool enough, I guess, for a beginner, but then that same beginner will spend 2 hours trying to figure out that issue because, well, they don't have the experience to figure it out immediately. And they also don't get an error message. It's just that the behavior is wrong and they don't understand why. When something like V2 will actually yell at you for doing that and you figure out the issue immediately. So same kind of idea with using indentation because it's quote-unquote simpler at the expense of the beginner who will actually suffer because of that. So that's what I think. Yeah, Hardship did a new vid about the new Java. Oh, huh. New Java, huh? HKV1 looped around to being inconsistent and hard to figure out. Precisely. That's my entire point on it. It was made to be quote-unquote simple, but it ended up being just so much harder than V2. True, V2 uses more complex structures, I guess, like the introduction of function objects, which, true, technically exist in V1, but you aren't really supposed to use them. But in V1, there's like this whole entire concept that you have to use, which at first is like difficult. But once you figure it out, it's so consistent and easy to use. It's so, like, understandable. When in V1, you have to know edge case after edge case for every single command. And that's why it's difficult. Okay, coming back. I don't think HK and Python are the same world to be compared. They're not, but they are similarly not enough. That's what I think. True, Python is way more enough than HK, no question about it, and I imagine it's faster. It would be really funny if it wasn't. But comparing to what I'm looking for, which is something like Rust, Python is so far away that it might as well be AutoHotkey. Like, no types. I imagine there are like languages without types that are still good. I can't name one though. But like that already is like heartbreaking to me. And type annotations and actual types are different things. Even though, yeah, you can annotate types, but the compiler won't care about those. It's not like, it's useful, I agree, but not as useful as actual types that the compiler will check. That set timer jank that I shared with you still haunts me to this day. Yeah. When in V2, you just pass a function object and here you go. Python has only one type. Really? Type variable. Okay, let's continue reading. Rust breaks down these barriers by eliminating the old pitfalls and providing a friendly, polished set of tools to help you along the way. Programmers who need to dip down into lower level control can do so with Rust without taking on the customary risk of crashes or security holes, and without having to learn the fine points of a fickle toolchain. Better yet, the language is designed to guide you naturally towards reliable code that is efficient in terms of speed and memory usage. Yeah, it's just a Python object. Oh, goddamn. It doesn't even have, like, background types, I guess. Like JavaScript, for example. It does, like, it has types technically. Like, at least, like, background types that you can check and so on. I mean, I imagine that's the same thing for Python, and you're talking about the actuality rather than what you come in contact with. It's just so sad to see. Something that I really liked about C#, or more specifically about OOP, about an OOP language, is that you can specify mega precisely what you're expecting and mega precisely what you're giving back. It is so powerful. Python is technically a C library. That's the funniest shit. I mean, at the end of the day, I do recognize that you shouldn't be using a single tool for every job. Well, I'm going to, but it's not like a good idea, I guess. It's not a reasonable idea, maybe. So Python has its place, most definitely. I just don't necessarily care about that place. It doesn't mean that it's a worthless language, that why does it exist? Like, no, like, it has a reason to exist. It's valid. I just don't care about it. Pretty much. Programmers who are already working with low-level code can use Rust to raise their ambitions. For example, introducing parallelism. Let me try again. Parallelism. Fuck, what a difficult word. In Rust is a relatively low-risk operation. The compiler will catch the classical mistakes for you. And you can tackle more aggressive optimizations in your code with the confidence that you won't accidentally introduce crashes or vulnerabilities. That's cool. But Rust isn't limited to low-level systems programming. It's expressive and ergonomic enough to make CLI apps, which is exactly what I'm going to be doing, web servers, maybe, who knows, and many other kinds of code quite pleasant to write. You'll find simple examples of both later in the book. Working with Rust allows you to build skills that transfer from one domain to another. That's one of the biggest reasons why I decided to learn Rust. I feel like if I learn Rust, any other language will be a breeze. Not to that extent, like I realize it, but pretty much. Like, if I come back to C# after learning Rust, the things that are mysterious to me right now in C# will no longer be so. You can learn Rust by writing a web app, then apply those same skills to target your Raspberry Pi. This book fully embraces the potential of Rust to empower its users. It's a friendly and approachable text intended to help you level up, not just your knowledge of Rust, but also your reach and confidence as a programmer in general. So dive in, get ready to learn, and welcome to the Rust community. You can do like everything but front-end web dev and Rust, right? Maybe even that you can with like WebAssembly, or is that backend? I feel like, yeah, that's backend only, right? But pretty much, and that's what I'm intending to do. Just do every single thing in Rust because it's cool. You can do front end and back end in the same code base with Laptos, which is why I want to learn it. Yeah, that's what I thought. So let's go. This edition. Cool. I don't know a single thing about WASM yet. I know that it's WebAssembly, and it's like very fast, but I have no idea how it works. Welcome to the Rust Programming Language, an introductory book about Rust. The Rust programming language helps you write faster, more reliable software. High-level ergonomics and low-level control are often at odds in programming language design. Rust challenges that conflict. Through balancing powerful technical capacity and a great developer experience, Rust gives you the option to control low-level details, such as memory usage, without all the hassle traditionally associated with such control. It's just like a JVM. My immediate thought is, oh, that sucks. Maybe it doesn't, but that's my immediate thought. Like, disappointment. Nothing else. Immediate thought, disappointment. Who is Rust for? Rust is ideal for many people for a variety of reasons. Cool, great explanation. Thank you. You answered the question so well. Let's look at a few of the most important groups. Teams of developers. Rust is proving to be a productive tool for collaborating among large teams of developers with varying levels of systems programming knowledge. Low-level code is prone to various subtle bugs, which in most other languages can be caught only through extensive testing and careful code review by experienced developers. That's true. I heard the tales of C errors being very hard to understand or figure out. And Rust, infamously, or rather famously, right? You use infamously when it's famous for bad reasons, and you use famous for, well, just famous. Yeah, and Rust is famous for having very good error messages. Maybe even the best error messages ever in any language. But I'm probably saying that out of ignorance. Surely there is one or two languages that are better in that regard, but I actually doubt it. Gene, what do you think about that? I got a water filter right in my room, so I have near infinite water until it's not. You need a degree in CS to understand CRs all the way. Yeah, fuck. It's almost like the name of my previous channel. In Rust, the compiler plays a gatekeeper role, which I love. What I love the most is when my every single error is a skill issue on my part. That is, important. If it's the language being, annoying / bad and so on, that's just... But if it's a skill issue on my part, that's my fault and I can accept that way easier. I like the messages, but I came from Python, so everything is better. Fair enough. I think Jesus, there are so many cars. I mean, to be fair, it's 9 a.m. here. And the reason why I have the window open is because I heat up like crazy when I'm speaking so much. I think I saw a few error messages from Python, and they were not very understandable. I like how I see my errors before I run the code. Yeah, that's very nice. Another hotkey. Let me reload my script. And in this place, you might have seen a few error boxes that would show you the the errors that AutoHotkey can figure out immediately. But that is not even most of them. It's only a small part, and most errors you'll figure out, and matter of fact, even won't, during runtime, which is incredibly annoying. Yeah. I wrote an API for work, and the Python errors have a stack 18 frames long that you have to debug. Jesus Christ. They're so loud. Okay. By refusing to compile code with these elusive bugs, including concurrency bugs, by working alongside the compiler, the team can spend their time focusing on the program's logic rather than chasing down bugs. That sounds so cool. Rust also brings contemporary developer tools to the systems programming world. Cargo. I've had a small experience with it, and I already quite like it. It's quite nice. The included dependency manager and build tool makes adding, compiling, and managing dependencies painless and consistent across the Rust ecosystem. The Rust formatting tool ensures a consistent coding style across developers. The Rust language server powers integrated development environment integration for code completion and inline error messages. I've already come in contact with that. I feel like I'm just gonna stream until I lose my voice and repeat until I learn Rust. Using Rust, many people have learned about topics like operating systems development. This community is very welcoming. I've heard that a lot and happy to hear your student questions. Through efforts such as this book, the Rust teams wants to make systems concepts more accessible to more people, especially those new to programming. But I feel like using Rust as your first programming language, I at the very least heard, and I'll probably agree very soon, that it's a crazy idea. Like, as a first programming language, goddamn. Even C# is a death sentence as a first programming language. I feel like Python is probably the perfect language as a first one, because I think a very important rule, or rather not rule, very important part of a first programming language is that it has to be kinda bad, but not quite. Kinda bad in the sense that for some things you'll have to understand them and implement them yourselves, and you'll see the pitfalls of a dynamic typed system yourself in practice. And then when you learn a better language, you're like, fuck, finally I have types, instead of starting with types and not understanding why you need them for the longest time. Which is, Python is probably like one of the, if not the best, first programming language. My condolences, goddamn mood. I pity that. Companies. Do I? Okay, let's start with this. This book assumes that you've written code in another programming language that doesn't make any assumptions about which one. That's good. Imagine if it just like gave examples, like, so to do this in Rust, you do it this way. It's kind of like it would be this in JavaScript. Like, imagine if it just picked JavaScript as an example. We've tried to make the material broadly accessible to those from a wide variety of programming backgrounds. Coming from Python to Rust, I realized how spoiled I was, but I never felt like I ever needed types in Python, because if I wanted to run something fast, I'd use pandas or a library written in C. Yeah, Python is very rich in terms of libraries. I heard that a lot. But learning Rust, I feel like, will improve your overall understanding of like everything and make you a better programmer. Even if you end up mostly using other languages, which I doubt. Especially for a person like me, I love being a cultist. I like finding a new toy and praising it until the end. I infamously love V2, for example. Like, as they say in Russia, don't feed me bread, let me talk about AutoHotkey V2. I feel like in DevOps I need to compile and package things. We don't spend a lot of time talking about what programming is or how to think about it. Thank you. If you're entirely new to programming, you probably shouldn't learn Rust first. You would be better served by reading a book that specifically provides an introduction to programming. Or, like, watch a tutorial, I guess. Reading books about programming, like, come on, I'm Gen Z, like, I don't read. I feel like there's a better word than cultist, lol, but sure. No, I am definitely a cultist. Like, I start using something like Vim or Linux, or anything of that sort, and I'll be a cultist about it. Like, for the longest time, after starting using Vim, I was like, there is no way that it's viable at all to not use Vim. I've calmed down from that opinion since then. I think it is viable to not use Vim, but you really should still. It makes things more comfortable, easier, and faster. Rust definitely attracts the cultist mindset. I'll probably become the classic Rust cultist. How to use this book? In general, this book assumes that you're reading it in sequence from front to back. Later chapters build on concepts in earlier chapters, and earlier chapters might not delve into details on a particular topic, but will revisit the topic in a later chapter. Ah yes, let us explain how books work. Thank you. You'll find two kinds of chapters in this book, concept chapters and project chapters. In concept chapters, you learn about an aspect of Rust. In project chapters, we'll build small programs together, applying what you've learned so far. Chapters 2, 12, and 20 are project chapters. The rest are concept chapters. So once again, how I'm going to go through this book is literally by just reading it all. Maybe like checking things out from time to time, but my intent is just hear everything about Rust, and then I revisit the book, actually delving deeply into each thing. Chapter 1 explains how to install Rust. Are you really gonna explain every single thing? Sure, I'll read it. I never read the book, I just started going at it. That's how I approach things as well, but I feel like going more fundamental will prevent me from making beginner mistakes, in a sense. Basically, getting a more fundamental experience and understanding, rather than rather than just grabbing whatever I know I need without recognizing the things that I do indeed need, but I don't know that I do need them. And I would Google each time I needed something. Yeah. I want to have an overall good foundation that I can build upon by Googling from then on. One is a CLI. Cool. Explains how to install Rust, how to write a Hello World program, and how to use Cargo, Rust's package manager and build tool. Chapter 2 is a hands-on introduction to writing a program in Rust, having you build up a number guessing game. Here we cover concepts at a high level, and later chapters will provide additional detail. If you want to get your hands dirty right away, Chapter 2 is the place for that. Chapter 3 covers Rust features that are similar to those of other programming languages, and Chapter 4, you'll learn the Rust's ownership system. That's so exciting. If you're a particularly meticulous learner who prefers to learn every detail before moving on to the next, which is not going to be our strategy for now, you might want to skip Chapter 2 and go straight to Chapter 3, returning to Chapter 2 when you'd like to work on a project applying the details you've learned. I agree with your perspective, I just can't motivate myself that way. I think a really big part as to why this will work for me is the fact that I'm streaming. If I can turn something into content, that's more exciting. And a bunch of my videos on my channel are from that. Like, I work on something, usually with the intent to then show it off in a video. And that is so incredibly motivating that it helps me actually finish things. And then maybe eventually No Boilerplate himself will appear on stream, and that will be like an epic moment. So yeah, I can afford to do this. I might not always. So for Lua, for example, yeah, I do the approach of get things and learn them once you need them, because I don't really care about Lua and it's another language that I hate and despise. But Rust, I already have a huge respect for this language and I want to give it the time that it deserves, which I haven't done for any other language. I guess I did to C#, but not to as good of an extent that I'm going to Rust. Because overall, I do like C#, but I don't necessarily respect it. It's like your weird older brother that didn't succeed in life. Like, yeah, I'll talk to you maybe, but I don't know. The other sister that did succeed in life and she's like very cool, I like her better, and she's Rust. If you're particularly returning to Chapter 2 when you'd like to work on a project applying the details you've learned. Chapter 5 discusses structs and methods. And Chapter 6 covers enums, match expressions, and the if-let control flow construct. I think I know what that means, and that's pretty cool. You'll use structs and enums to make custom types in Rust. Good to know. Yeah, pretty much. Which is why I don't necessarily respect it. And I started learning C# specifically to get a job. And Rust is more like an actual thing. Oh, right, you're so right. Rust is like your youngest child. He's very good at math, but you don't know if he will become a serial killer. That's so true. Yeah. In Chapter 7, you'll learn about Rust's module system and about privacy rules for organizing your code. And its public application programming interface. Chapter 8 discusses some common collection data structures that the standard library provides, such as vectors, strings, and hash maps. Nice. Chapter 9 explores Rust's error handling philosophy and techniques. Chapter 10 digs into generics, traits, and lifetimes, which give you the power to define code that applies to multiple types. Chapter 11 is all about testing, which even with Rust's safety guarantees is necessary to ensure your program's logic is correct. In Chapter 12, we'll build our own implementation of a subset of functionality from the grab command. Holy shit! Line tool that searches for text, I know, within files. For this, we'll use many of the concepts we discussed in the previous chapters. That's so cool! Wow! I'm working on replacing my batter. Do you mean battery or batter as in like you're cooking something? Either way, good luck. So sorry, I'm not chatting a bunch. No worries, like even if you just have the stream on background, that still is nice. Where were we? Yeah, we're gonna make grep. That's so cool. Chapter 13 explores closures and iterators. Features of Rust that come from functional programming languages. In Chapter 14, we'll examine cargo in more depth and talk about the best practices for sharing your libraries with others. That's very interesting because it's still one of the things that I don't know in any language. Libraries are just kind of all over the place and I don't really understand how I'm supposed to be using them. So I feel like I'm finally going to be able to figure out how to use it in Rust correctly. Battery. Oh, okay. Thought he was maybe cooking. Let him cook. Let him cook. Chapter 15 discusses smart pointers that the standard library provides and the traits that enable their functionality. Interesting. I'm gonna learn pointers, I guess. In Chapter 16, we'll walk through different models of concurrent programming and talk about how Rust helps you to program in multiple threads fearlessly. Because it is super easy to use the cargo system in Rust. That's so exciting. Because in other places, well, AutoHotkey doesn't even have it. Just share the file. Well, AutoHotkey is both brilliant and stupid because it's very simple. It works very simply. Look at this, for example, includes, which is the alternative of import in other languages. How does an include work? Well, it literally places the contents of this file, of this file as if it's in this current file. So what's in this will now be literally in HK test. So it works very simply. No bundling, no like module separating, whatever. You just take the text and put it here. Very simple. And I actually like it a lot. I think that's great. And AutoHotkey is over the place with that simplicity. But I guess as you grow your project, this will become bad in some ways. I haven't really reached that point, or maybe I didn't realize that I have. So with something more robust, like Rust's package manager, I feel like I'm gonna reach heaven. It doesn't convert it to an object. Oh, yeah, you mean about this. Yeah. Literally just pastes it here. Which is like both good and bad depending on what you're looking for, and I feel like for AutoHotkey, that's the best possible approach. For what AutoHotkey is supposed to be. That's how it works in Rust, but Rust won't let you write code into the body like AutoHotkey would. Mm-hmm. It would let you import those public functions not named main. I see. Yeah, that makes sense. And I imagine that's how most libraries are done. You get the thing, but you don't really get access to it. But with a hotkey, you just have access to everything. There's no private things in a hotkey, unfortunately, which I hate. It's different from how Python does it, where you can pick different methods of import. I already looked at importing, and it's like use std and like IO, but you can also do it in brackets where you do self, and then say write or something. So there's that method as well. Not quite sure yet how it works, but I'll guess I'll figure it out. Import everything from or import module. Importing everything, I heard that it's a bad idea, and you don't need much experience to figure out that it's true. Unless like for really simple things, maybe. I still want to have my stream like lab, I guess, open so I can like check on health of the stream and see how long I've been streaming for, so I'll know when to eat. However, where is it? How do I like the current stream? Oh, okay. Wait, I already popped out chat. What? Lol. Okay. An hour and a half. Okay, good to know. I use import everything from something when I have a common library. Yeah, fair enough, yeah. I don't think you can import self. That's what the Rust like IntelliSense said, or rather, that's the change that the Rust IntelliSense did for me. Or rather, I was making a wrong example. More specifically, use std IO, and then here you can do self, and then write, and so on. So this. That was an incorrect example. That's what you can do, apparently. But the method you showed is for importing multiple submodules. I use import everything from, oh yeah? Like logging colors. Huh. 87 minutes. True. 87 minutes. Hello. We're reading the Rust book. Welcome. So where were we? Chapter 13 explores yes. In chapter 14, we'll examine cargo in more depth and talk about best practices for sharing your libraries with others. Chapter 15 discusses smart pointers that the standard library provides and the traits that enable that functionality. I read that already. In chapter 16, we'll walk through different models of concurring programming and talk about how Rust helps you to program in multiple threads fearlessly. Chapter 17 looks at how Rust idioms compare to object-oriented programming principles you might be familiar with. So yeah, I'll probably have to read, or rather write code in a very different way, which is both scary and exciting. Self refers to referring to your own implementations. You will see soon. Huh. Self refers to referring to your own implementations. I guess I will. Yeah, not even a book. It's called the book, and it's always like mentioned as the book. My name is not Alex. If you want to use my first name, then it's Alisa, but my nickname is Axel Fubler, which I do realize is hard to pronounce. It works the same way in Python, the self-references. Have motivated me to work on my own project. Fuck yeah! I'll check back on you soon. Alright. Chapter 18 is a reference on patterns and pattern matching, which are powerful ways of expressing ideas throughout Rust programs. Chapter 19 contains a... Is that a real word? I guess it is, right? Smorgasbord. A smorgasbord. It's like the Russian word biliburda, which is really funny, by the way. Of advanced topics of interest, including unsafe Rust, macros, and more about lifetimes, traits, types, functions, and closures. In Chapter 20, we'll complete a project in which we'll implement a low-level multi-threaded web server. Holy shit! I'm gonna learn that? Jesus Christ! Oh, my bad, I don't know why I read as Alex instead of Axel. Understandable, like, when the way we read words to begin with, we don't read it letter by letter. We look at a word, see its shape, and we perceive it. That's how we read. So, reading Axel, something that doesn't happen often at all, as Alex is like, yeah, that's your brain trying to help you, but not doing so in the end. It means chaotic mess, or just a big bunch. Yeah. Checks out. Yeah, but this is crazy. Finally, some appendices contain useful information about the language in a more reference-like format. Appendix A covers Rust's keywords. Appendix B covers Rust's operators and symbols. Appendix C covers derivable traits provided by the standard library. Appendix D covers some useful development tools, and Appendix E explains Rust additions. In Appendix F, you can find translations of the book, and in Appendix G, we'll cover how Rust is made and what nightly Rust is. The newer releases of Rust. There is no wrong way to read the book. If you want to skip ahead, go for it. You might have to jump back to earlier chapters if you experience any confusion, but do whatever works for you. I wish I could work on my project, but the said battery I'm replacing is for my laptop. Ah, I see. That's unfortunate. Sometimes you want to program so bad, but you're stuck doing something else. I'm the type of girl that will like go to a party because I was supposed to, and then like not even halfway through it, get too drunk because I feel uncomfortable because I'm an introvert, believe it or not, and then leave so I can come back home to program. Which is stupidly nerdy, I realize. And that's why I'm mostly at home nowadays. An important part of the process of learning Rust is learning how to read the error messages the compiler displays. This will guide you towards working code. As such, we'll provide many examples that don't compile along with the error message the compiler will show you in each situation. Know that if you enter and run a random example, it may not compile. That's so adorable because they understand very well how beginners do things. They do things in a way that is very chaotic and without deep understanding, so they'll just copy everything and run it and then be confused. So they immediately say something about this, which is really nice. This is what programming as a hobby does to somebody. So true. I mean, come on, I'm trans. Like, Would I figure it out if I wasn't a programmer? I don't fucking know. Maybe not. The fucking pipeline. And now, guess what I'm doing? Learning Rust, the transest thing to ever exist. So, true. So true. But I do intend to eventually earn money on this. And then move and have a better life. I feel like learning Rust will propel me into a much better developer overall. Even in worse languages. Make sure to read the surrounding text to see whether an example you're trying to run is meant to error. Ferris will also... His name is Ferris. Aww, he's so cute. Will also help you distinguish code that isn't meant to work. This code doesn't compile. This code panics. That's so adorable. That's so cute. Aww. So cute. I don't know why, but I want to download them as logos so I can use them. Oh, it's an SVG. I guess that's good rather than bad. The code does not produce the desired behavior. Yeah, maybe I'll use them somewhere. In most situations will lead you to the correct version of any code that doesn't compile. That's so nice. So they'll like show everything. That's great. The source files from which the bug is generated can be... The bug is generated. That's so cool. I guess, yeah, it would be, but still. Like, available, like, yeah, you can have them. Ah, I love that. Let's start your Rust journey. There's a lot to learn, but every journey starts somewhere. True. In this chapter, we'll discuss installing Rust on Linux, macOS, and Windows. Windows being the most annoying one of them all. Writing a program that prints hello world, literally 2 commands, which is can, and I guess you name it, and car, and that's it. I guess you would CD into it, because it starts out with the hello world. And it's very simple, like, yeah, very simple. Using cargo, Rust package manager, and build system. Installation. We'll download Rust through RustUp, a command line tool for managing Rust versions and associated tools. You'll need an internet connection for the download, naturally. If they're gonna be this, like, specific, I'm gonna have a good time with this book. If they're this specific, rather than expecting you to know everything to begin with. Like, such small, obvious details. If I prefer not to use RustUp for some reason, That's the coolest part about Rust, the fact that even with newer versions, all of the previous Rust code will still work. And that is so cool, because with something like C#, that's just not the case. The output might differ slightly between versions because Rust often improves error messages and warnings. In other words, if any newer stable version of Rust you install using these steps should work as expected with the contents of this book. Command line notation. In this chapter and throughout the book, we'll show some commands used in the terminal. Lines that you should enter in the terminal start with a $sign. You don't need to type the $sign character. I know, it's the command line prompt shown to indicate the start of each command. Lines that don't start with $sign typically show the output of the previous command. Additionally, PowerShell specific examples will use instead of the $sign. Using this, use this. I already did. The command downloads a script and starts the installation of the RustUp tool, which installs the stable version of Rust. It's like a Matryoshka doll. You might be prompted for your password. If the install was successful, the following line will appear. Nice. You will also need a linker, which is a program that Rust uses to join its compiled outputs into one file. Interesting. It is likely you already have one. If you get linker errors, you should install a C compiler, which will typically include a linker. A C compiler is also useful because some common Rust packages depend on C code and will need a C compiler. That's so specific. Why macOS? Okay, I'll install this, I guess. They have to explain the $sign symbol. Yeah. But I love this approach because it's like they make sure that even the dumbest people, and I'm gonna be real, yes, the dumbest, if you try to approach Rust without knowing that the $sign usually means the prompt symbol in your usually Linux terminal, I think you're just dumb, or at the very least very underqualified to be learning Rust. And that's probably me gatekeeping. And if you're willing to go through hell, then sure, like, go ahead. But I think learning Rust as a first thing is just goddamn. So if you don't know that the $sign means the prompt, are you ready to learn Rust? I don't know. I wouldn't say so. Let's just check that I did it correctly, because I do have Rust installed on both Linux and Windows because I need it for the extension to work. On Windows, go here and follow instructions for installing Rust. At some point in the installation, you receive a message explaining that you also need these tools, which I did install. Yes. Yes, the rest of the book uses commands that work on both CMD and PowerShell. If there are specific differences, we'll explain which to use. Wait, does it automatically... No, I hope it's going to always include the Linux commands, because I don't want it to assume that I want it to give me Windows stuff. I don't care about that. To check whether you have Rust installed already, okay, Rust C and 3 version. I do, 170. You should see the version number, commit hash, and commit date for the latest stable version that has been released in the following format. Yeah. Cool. If you see this information, you have installed Rust successfully. I did. And if you don't see this information, check that Rust is in your path system variable as follows. Echo path, yes, that's all correct, and Rust. If that's all correct and Rust still isn't working, there are a number of places you can get help. Find out why. I have everything installed. Also, Rust Stations is so cute. Updating and uninstalling. Once Rust is installed via Rust up, updating to a newly released version is easy. From your shell, run the following update script. I love that. Like, that's why I love Linux. Or Unix oriented CLIs. You just, the command, update, or this, like, I love that. The installation of Rust also includes a local copy of the documentation so we can read it offline. Okay, let's do Rust up doc. All Rust users are canonically crabs. So true. Wait, I thought, oh, I might have not Rieta that. Yeah, now it works. Ooh. Hold up, let's quickly go through it. Learning Rust, the Rust programming language, so is the book, Rust by example, so it's included in the actual docs. That's good to know. Rust links, Rust playground. I like having my own things for testing using Rust. Your personal. cargo dock open. That's so cool. That's so nice. But we'll get to it after a bathroom break. But as usual, I will streamer gone. I'm back. What a command, lol. You give me so much inspiration. Thank you. Yeah, it's very simple. You just type in a thing that you want to store. Very useful for, like, say, there's something here that you can't copy, but you want to keep. Maybe it's a screenshot, so you just go boom and you type it in, and then you go to the thing where you actually need to use this information. You type it in, right? And like, here you go. Then you can close it. But often not that necessary, because I can just take a screenshot and make it appear and do the same thing. Make it appear multiple times, actually. I have many very useful tools. Okay, yeah, but this is so cool. Like, the docs, they're local, and you can automatically create documentation for your project, like, automatically. That's like, I love that shit so much. It's already, like, giving very quality things about a language that I have not really seen in other languages, or at least not seen explained this well. Anytime a type of or function is provided by the standard library, you're not sure what it does or how to use it, use the application programming interface documentation to find out. Okay. So this is the actual start, I imagine. Hello world, now that you've installed Rust, it's time to write your first Rust program. I'm fucking around with my words. Hold up. Ah, yes, vaping will help me read better. Sorry, not able to watch for a minute or so. No worries. It's traditional when learning a new language to write a little program that prints the text "Hello World" to the screen, so we'll do the same here. This book assumes basic familiarity with the command line. I hope so. Rust makes no specific demands about your editing or tooling, or where your code lives, so if you prefer to use an integrated development environment instead of the command line, feel free to use your favorite IDE. Many IDEs now have some degree of Rust support. Check the IDE's documentation for details. The Rust team has been focusing on enable great IDE support via Rust Analyzer. Yeah, that's exactly what I'm using, and it's amazing so far. Creating a project directory. You'll start by making a directory to store your Rust code. Doesn't matter to Rust where your code lives, but for the exercises and projects in this book, we suggest making a projects directory in your home directory and keeping all your projects there. Open a terminal and enter the following commands to make a projects directory and a directory for a Hello World project within the projects directory. Okay, so I'm thinking of how I want to do this. Okay, learning, well, I want to have a test directory, and I intend to use learning as that. And then when I revisit the book after reading it fully, that's when I have a learning directory. Hello. So what is the changes? Cargo lock. Yeah, I guess add cargo lock. Boop. So far, learning is not where I'm going to be. I'm going to be in a test directory. Yeah, so let's actually no make dirt. Let's use new test and creates a folder. It's a function that Misha wrote for fish. Let's go to test and cargo init. Oh. If you needed a binary with the name test, use a valid package name and set the binary name to a different name from package. That's interesting. I'll need to fix this. And I know how to do it. Let's go to type functions and open it in another VS Code window. Hello? Hey, at least they tell you it conflicts rather than just giving you a bogus error. So true, so true. And it also explains... Interesting, it didn't actually open. And now it's... My mouse is permanently goofy. Ow. I didn't place the dot, that's on me. Yeah, so it also explains pretty understandably that your directory name is assumed to be your package name, which is very interesting to know. Wait, you're saying that learning is not a taken package name? No way. Okay, so I'm looking for status. So instead of putting it at the end, actually I do need at the end as well as at the start. So echo an S and a space. So now when I do fa, it works. But if we go to something like lib and do fa, there are two spaces here now, which is not what we should have. So now go to get, and I put a space after. I see now. So the current issue, and the prompt, here's the PWD, and after that we need to somehow have a space. We need to guarantee that there will be a space. In that case, let's put a space after PWD, after get, and after status, but not before status, which is the change they just made. That should be on this level, but it doesn't really matter since it's not fucking Python. Okay. At the end of get and at the end of status, it should be using tabs, by the way. Why? Because I like them more. Oh, this and this. Okay. So get status, still jabbing at Python, yes. Yeah. And now for PWD. So is there like, no, not here, in config. My mouse is still weird. PWD. Yeah, pretty sure there is no like suffix or prefix, because if there were, I would be using that. So printf and then a space should do the trick. There are now two spaces here. I think because of my configuration for get, wherever it is, yeah. So that's just boop. So you can consider that this works, and let's do fa. And it eventually appears. And the reason why I'm putting a space after is so this still displays. If I didn't, the 7 would disappear and it would be error 12, which it is not. Okay, cool. Let's go back to Rust. So test, let's rename it to something. Test proj. Sure. Let's do test into test proj. The test proj. So cargo init. Right. So it expects me to want to use get. Since this is a test project, it will be ever changing. So I actually specifically don't want either the get or get ignore. I don't want it to track anything. Cool, so now I have this test project. And let's go to type functions, commit the change that I just made. What did we actually change? Space after BWD, spaces only after other items. That's a good enough commit message. So I can close this window. All of those changes I can do later. Yes, and this is the learning. Learning I'll come back to once I reread the book and start doing actual stuff. Then it will be useful. But for now, we go to Rust and then to learning. No, not to test project. Okay, and before we continue on, we should add it to plain directories. Here it is. No, that's not what I wanted to do. Test proj. Yes, test proj. Okay, let's blip and open it in VS Code so we can try out code. Great. And then later when I come back to it, I'll rename that repository for learning into something like going by the book or so on, to explain the idea clearly. But we're back. So we did that. And yeah, my idea is to go through everything, but not really do it. Just, yeah, as No Boilerplate said, not worry about how many errors I get, and then actually doing it properly. Writing and running a Rust program. Make a new source file and call it main rs, but it's done for me. Oh, it's trying to teach me how to do it without cargo. Rust files always end with the rs extension if you're using more than one word in your file name. The convention is to use an underscore. I'm used to using dashes or hyphens in spaced names. But I guess you should be using underscores, okay, to separate them. For example, use hello world rather than hello world. True. Now open the main rs file you just created and enter the code list in listing 1.1. Save the file and go back to a terminal window on Linux on my oh wow, why are you Rust seeing it? Shouldn't you just cargo run? Interesting that it shows that way first. Interesting. Okay, sure, let's do it that way then. Rust. Wait, where are we? Sure. Rust C main rs. That's what I thought. Just put spaces in the file path. Seriously though, this causes so much pain for devs. Yeah, that's why I don't. Like, if I don't put spaces, I'll have to think less about which program does or doesn't support spaces. And yeah, it's as usual, it's in target, then what? Then debug, and then deps build, I guess. Okay, let's go there. Let's go to build. Interesting. Oh, hold up, I didn't notice this. So now we have main. Interesting. Huh. So that's how we do it without cargo. Interesting. I mean, technically. Anatomy of a Rust program. Let's review this Hello World program in detail. Here's the first piece of the puzzle. These lines define a function named main. The main function is special. It is always the first code that runs in every executable Rust program. Here the first line declares a function named main that has no parameters and returns nothing. If there were parameters, they would go inside the parentheses. The function body is wrapped in this. Rust requires curly brackets around all function bodies. Good. It's good style to place, I agree, place the opening curly bracket on the same line as the function declaration, adding one space in between. If you want to stick to a standard style across Rust projects, you can use an automatic formatter tool called Rust Format to format your code in a particular style. Ooh, more on Rust Format in Appendix D. Okay, I want to save this for later. To Rigel. Explain this link. Rust formatter. All right, I should also toggle it here. But yeah, that's later. Like, I won't go into depth on any single thing. I'm just supposed to go through it. It's like a new way of learning for me, but I'll trust it. Oh, come on. Fuck you. I use tabs. Second, Rust macro. If it had called the function instead, it would be entered as print line without the exclamation mark. We'll discuss Rust macros in more detail in chapter 19. Oh wow, that takes a long time. Fourth, we end the line with a semicolon, which indicates that this expression is over and the next one is ready to begin. Most lines of Rust code end with a semicolon. Okay. Compiling and running are separate steps. You've just run a newly created program, so let's examine each step in the process. Before running a Rust program, you must compile it using the Rust compiler by entering the rustc command and passing it the name of your source file like this. I mean, yeah, but not really, because cargo run and cargo build is what you're really supposed to use, I'm pretty sure. This is for like more, I guess, simple stuff, but still very important to know. If you have a C or C++ background, you'll notice that this is similar to GCC or CLang. After compiling successfully, Rust outputs a binary executable. On Linux, Mac OS, and PowerShell on Windows, you can see, I don't care. Are you sure? Does PowerShell have ls? Let's check that. I don't believe it. Oh wow, PowerShell has ls. I still don't like it because it's ls-g by default, or rather -l, I guess is what people most know. But at least there is an ls. It doesn't exist in CMD. You have dir, which is even uglier. Yeah, on Windows you get the exe. I specifically don't want that. And you're like the crazy PowerShell junkie. Yeah, I'm surprised. This shows the source code file with the rs extension, the executable file, main exe on Windows but main on all other platforms, and when using Windows, a file containing debugging information with the pdb extension. From here, you run the main or main exe file like this. If your main rs is your hello world program, the line prints hello world to your terminal. If you're more familiar with a dynamic language such as Ruby, Python, or JavaScript, you might not be used to compiling and running the program as separate steps. That's fine. And for the most part, you can have that as a single step because cargo build. And I imagine that's what you should be doing to begin with. Rust is an ahead-of-time compiled language, meaning you can compile a program and give the executable to someone else, and they can run it even without having Rust installed. That's the coolest fucking shit about it. Like, that's so cool. And technically, I have the option of compiling to exe if I need to, so I can easily write a Rust program and just give the exe to someone and they just run it, and that's it. With C#, it's quite a bit more annoying. This is simpler, at least it feels that way. If you give someone a ruby.py or JS file, they need to have a Ruby, Python, or JavaScript implementation installed, respectively. Sorry. But in those languages, you only need one command to compile and run your program. Technically, the same case goes for Rust. You're just not showing it right now. Everything is a trade-off in language design. You're trying to act humble. No, you're just better. Just compiling with Rust C is fine for simple programs. That's what I thought. As your project grows, you'll want to manage all the options and make it easy to share your code. Next, we'll introduce you to the Cargo tool, which will help you write real-world Rust programs. Okay, how long have I been streaming for? Oh, just was updating very slowly. 2 hours. When did I eat? I woke up at around 5 a.m. Started eating at, I think, 6. I should be mega hungry at this point. Why am I not? Oh well. Well, essentially, I'll end stream once I'm hungry, which I don't know will happen yet. That's why I like HK compiling as well, since you don't actually need HK. Yeah, it's so nice. You just right-click compile, which what other language has that? And that's it. And you just give the exe and that's it. When it was something with like Python, I heard that it's way more annoying. with cargo, it will only use the part of cargo that handles building your code. As you write more complex programs, you'll add dependencies. If you start a project using cargo, adding dependencies will be much easier to do. So for that reason, I'm just gonna remove main. Yeah. Is there something like, no, not this, cargo clean? Yeah. See, I just guessed that. Let's add that as a thing. Ah, yes. Cargo abra, cargo clean, cackle. Cargo clean. So we have cargo. Should also add cargo build, because surely that's a thing. I would be very surprised if not. Yeah, and I've used it before. And now when I look, we have target. I can cackle to clean it. It's very similar in C#, right? But for some reason, this feels just kind of nicer. Not sure why. So far, really good feeling about the language. Yeah. If you see a version number, you have it. If you see an error, such as command not found, which is error 127, which I think is just kind of cool to know. Look at the documentation for your method or of installation to determine how to install cargo separately. Creating a project with cargo. Let's create a new project using cargo and look at how it differs from our original Hello World project. Navigate back to your project directory or wherever you decided to store your code. Then on any operating system, run the following. Cargo new this. The first command creates a new directory and project called Hello Cargo. We've named our project Hello Cargo, and cargo creates its files in the directory of the same name. Go into the Hello Cargo directory and list the files. You'll see that cargo has generated 2 files in one directory for us, a cargo toml file and a source directory with a main rs file inside. It has also initialized the new git directory along with the gitignore file. Git files won't be generated if you run cargo new within an existing git repository. Would you look at that? You can override this behavior by using cargo new vcs equals git. That's cool. Git is a common version control system. You can change cargo new to use a different version control system or no version control system by using the VCS. Run cargo new -- help to see the available versions. Let's do that. Cargo new, right? Can HL. We have quiet registry to use. Interesting. Initialize a new repository for the given version control system. Or do not initialize any version control at all. None. Overriding a global configuration. Quite a lot of stuff, huh? Nice. Open cargo toml on your text editor of choice. It should look similar to the code in listing 1, 2. Yes, and let's do exactly that. Toml, which turns out I can press capital U to make it not a preview editor. And it does, yeah. Cool. This file is the Tom's obvious minimal language format. That's a funny name, which is cargo's configuration format. The first line, package, is a section heading that indicates that the following statements are configuring a package. As we add more information to this file, we'll add other sections. The next 3 lines see the configuration information Cargo needs to compile your program. The name, the version, and the edition of Rust to use. I see. We'll talk about the edition key in Appendix E. Every time you're in VS, you always jiggle the pointer up and down. Do I? Oh, I guess I do. It's really fun to do, especially with the smooth cursor. The last line, dependencies, is the start of a section for you to list any of your project's dependencies. In Rust, packages of code are referred as crates. We won't need any other crates for this project, but we will in our first project in chapter 2. So we'll use this dependencies section then. It feels so like simple and easy compared to some other dependency managers like NuGet. While technically okay, it feels pretty barbaric, I guess. Now open source main and take a look. Cool. Cargo has generated a Hello World program for you, just like the one we wrote in listing 1.1. So far, the differences between our project and the project Cargo generated are that Cargo plays the course code in the source directory, and we have a Cargo toml configuration file in the top directory. Cargo expects your source files to live inside the source directory. The top-level project directory is just for README files, license information, configuration files, and anything else not related to our code. Yeah, I like that. Using Cargo helps you organize your projects. There's a place for everything, and everything is in its place. If you started a project that doesn't use Cargo, as we did with the Hello World project, you can convert it to a project that does use Cargo. Move the project code into the source directory and create an appropriate Cargo toml file. I expected it to basically Cargo init, doing exactly that. At the very least, creating a Cargo toml file if it doesn't exist yet. But I guess it doesn't? I guess it doesn't. Building and running a Cargo project. Now let's look at what's different when we build and run the Hello World program with Cargo. Exclamation mark. Is Cargo a macro? From your Hello Cargo directory, build your project by entering the following command. Yes, we build it. This command creates an executable file in target debug and then the actual thing. You can just, once again, just like give to your Linux user, they execute it and it's like, ah, that's so cool. Ooh, that's a good question that I'm currently having. Is there a way to compile to exe on Linux? Basically compile for Windows on Linux. That is interesting. My immediate thought was to go to ChatGPT and ask that, but I'll actually just give the time of day to the book and learn properly, rather than in the current directory. That's good, because the default build is a debug build. Cargo puts the binary in a directory called debug. You can run the executable with this command. If all goes well, it should print to the terminal. Running Cargo build for the first time also causes Cargo to create a new file at the top level, Cargo lock. This file keeps track of the exact versions of dependencies in your project. This project doesn't have any dependencies, so the file is a bit sparse. You won't ever need to change this file manually. Cargo manages its contents for you. We just build a project with Cargo built and ran it with this. But we can also use Cargo run to compile the code and then run the resultant executable on all in one command. I wonder if basically Cargo run, like, can I use Cargo run to just run without compiling? Name of the bin target to run. Example. Package. Parallel jobs. Keep going. Release. Oh, that's cool. Reversing an encrypted exe would be impossible. That's not what I'm talking about, I think. Something like the HK just has the bin file in your code to interpret, so something like this is reversible. Yeah, I know. Yeah, I know. What I'm essentially saying is, can I compile Rust for Windows from Linux rather than having to use cargo from Windows? I'm not really talking about reversibility at all. Basically, can I make a Rust program for a Windows user if I'm a Linux user? That's my question. Say there's a friend that says, oh, can you make this program for me that does this little thing? I'm like, sure. And I compile it for them for Windows. Like, can I do that? That's my question. Oh, I see. Frozen, profile, features locked, all features offline. Offline is pretty cool, run without accessing the network. I guess no. I mean, fair enough when it's like this simple. Target, debug, and then the name. Oh, main. No? Really? Oh, because I haven't compiled it yet. Right? Cab. Oh, not dab. Cab. Target, debug, main. Oh, test project, because it's now the name of the project instead of the main file, which is how it's supposed to be. So we just do target debug test project, and we can run it. I think if you have cargo installed on Windows and call the command from WSL to bit, the exit could work. Yeah, that's the current way I would do it. I'm also asking of can I do it when I only have Linux, because eventually I'm gonna switch to Arch Linux completely and not use Windows at all. So the question is what do I do in that kind of situation, you know? Because right now, yeah, I'll just do cargo or the ka and then add the exe, and it should work basically. Or whatever it's actually stored on Windows, but yeah. I have a way to do it now, but I won't later, and I'm wondering how I do it after. Okay. It's more convenient than having to remember to run cargo build and then use the whole... Yeah, I agree. Notice that this time we didn't see output indicating that cargo was compiling hello cargo. Cargo figured out that the files hadn't changed. That is so big. That is so big. I think for C#, it still recompiles before running, even if nothing has changed. So this is so actually big. Let's do car. Yeah. It's still it's checking stuff, because not much has changed. It compiles the changes if they can be compiled separately. Oh my god, I'm gonna come right now because that's so good. So we didn't rebuild, but just ran the binary. If you had modified your source code, cargo would have rebuilt the project before running it, you would have seen this output. Cargo also provides a command called cargo check. This command quickly checks your code to make sure it compiles and doesn't produce an executable. That is so big, actually. Car check. Cool. So maybe I don't want to compile it or care to run it. I just want to make sure something actually compiles without compiling it. That's very nice. Let's add an abbreviation for that. Sure. Check. And cargo check is being consistently run in here when I'm running, like creating stuff. So print this, hello again. Cargo check is consistently running here to check for stuff, and that's how the linter in the Rust analyzer works. Slightly fun fact. Catch. Cool. That's great. I love cargo so far. Way more than the .NET thing. The .NET client. I like cargos like a lot more so far, even though the differences aren't particularly huge. Why would you not want an executable? Often cargo check is much faster than cargo build. If you're continually checking your work while writing the code, using cargo check will speed up the process of letting you know if your project is still compiling. That's so cool. Like, I know that's the concept of a linter, but using that in the command line is so cool. As such, many Rustaceans run cargo check periodically as they write their program to make sure it compiles. Wow. Then they run cargo build when they're ready to use the executable. That's so cool. Oh my god. I love that so much. I've never seen this in any other language. That's incredible. Let's recap what we've learned so far about cargo. We can create a new project using cargo new. We can build the project using cargo build. We can build and run a project in one step using cargo run. We can build a project without producing a binary to check for errors using cargo check. Instead of saving the result of the build in the same directory as our code, cargo stores it in the target debug directory. Correct. An additional advantage of using cargo is that the commands are the same no matter which operating system you're working on. It's very nice. So at this point, we'll no longer provide specific instructions for Linux and macOS versus Windows. That's great. Building for release. When your project is finally ready for release, you can use cargo build -- release to compile it with optimizations. Oh, that's cool. This command will create an executable in target release instead of target debug. The optimizations make your code run faster, but turning them on lengthens the time it takes for your program to compile. So that's why. This is why there are two different profiles. One for development, when you want to rebuild quickly and often, and another for rebuilding the final program you'll give to a user that won't be rebuilt repeatedly, and that will run as fast as possible. That's so nice. If you're benchmarking your code's running time, be sure to run cargo build release and benchmark with the executable and target release. Now, a lot of things that are being explained here are very similar in C#, so why am I like so surprised, right? It's the openness, clearness, and I guess niceness of this entire thing that surprises me to such an extent. The way that it's so like so robust, just like the fucking type system. Cargo as convention. With simple projects, cargo doesn't provide a lot of value over just using Rust C. similar to how it is in C#, but it will prove its worth as your programs become more intricate. Once programs grow to multiple files or need a dependency, it's much easier to let Cargo coordinate the build. Even though the Hello Cargo project is simple, it now uses much of the real tooling you'll use in the rest of your Rust career. Fuck, that's great. In fact, to work on any existing projects, you can use the following commands to check out the code using Git. Change to that project directory and build. Yeah. Now I can just, like with C#, what I have to do, say I want to get a project that was written in C#. How do I compile it? I install another fucking SDK, because chances are they're not using the latest one, which is what I am using. Or maybe at some point I am not going to be using the latest one. With Rust, I just clone it and compile it. Done. That's so good. Summary. You're already starting off to a great start on your Rust journey. In this chapter, you'll have learned how to install the latest stable version of Rust, update to a newer Rust version, open locally installed documentation, write and run, create and run a new project using the conventions of Cargo. This is a great time to build a more substantial program to get used to reading and writing Rust code. So, in Chapter 2, we'll build a guessing game program. If you would rather start by learning how common programming concepts work in Rust, see Chapter 3 and then return to Chapter 2. I might actually do that. Well, no, it's in this kind of order, so I'll follow it. Yeah, I'll go through a bit more still. I'm very excited. I imagine I was also very excited when I started learning C#, but I feel like this has more value to it. The almost square windows are so cute. Programming a guessing game. That was Chapter 1 only? Yeah, I mean, there are 20 of them, or 19. That's not too bad, but yeah, Chapter 1 only. So it will take a lot of time, but you know what that means? A lot of content, and finally, for the first time, getting more foundational knowledge when learning a language, rather than going through stuff but not quite all of it. Let's jump into Rust by working through a hands-on project together. So starting from this, I will not actually be making the whole project. I'll just be going through going through how they do it to get accustomed to everything in Rust, and then come back to actually do more hands-on stuff. To a few common Rust concepts by showing you how to use them in a real program. You'll learn about let, match, methods, associated functions, external crates, and more. We'll explore these ideas in more detail. In this chapter, I'll practice the fundamentals. We'll implement a classic beginner programming problem, a guessing game. Here's how it works. The program will generate a random integer between 1 and 100. That's cute. And then prompt the player to enter a guess. That's so cute. After a guess is entered, the program will indicate whether the guess is too low or too high. Oh. If the guess was correct, the game will print a congratulatory message and exit. Setting up a new project. To set up a new project, go to the project directory. First command, cargo new, takes the name of the project. guessing game as the first argument. The second command changes to the new project's directory. Really? Generates a hello world program for you. Yes. Now it hello worlds. Yeah, that's how you program regardless. Don't do it in main. Move this out to a separate function, come on. Okay, so print line, guess the number. Please enter your guess. Create a mutable string. String being a namespace, actually. No, being a class. Let's check this out because let mutt. No, not mute, mutt. Guess is string. So it's a class. This in this case. Is still the operator for namespace. New okay. String is a struct, not a module. I love that it actually takes my font to, yeah. Oh, that's cool. Not a module. Interesting that it works for them, but not for me. Yeah. Yeah, but this is intentional. Wow. Prefix it with an underscore. What is intentional? Okay. I guess it expects variables to start with an uppercase letter? No way, right? Variable does not need to be mutable. This on by default. Remove this. I really like this. It being hyper specific that this doesn't need to be this way, instead of whatever, like it usually is in other languages. Wow. How do I think this? No. Control 6? No. Control 5? No. Control 4? Yes. And that's pretty interesting. Once I check out the error, it gets removed. Interesting. Once again, I'm more so looking at stuff rather than discovering it fully, amassing knowledge of stuff that I'll later have to learn. And once I get to it, yeah. Once I get to all of it, I'll have seen it in some sort of sense, and I'll like, oh right, I remember this. Now let's get more deep into it, rather than seeing it for the first time. I'm starting to recognize the value of starting by not doing everything, and then continuing on by redoing everything. So yeah, we create immutable string, which is nothing, and that's why it's mutable. I imagine that's not how you should do it. Just a guess though. IO, stdin, I love that. And you read line into this variable. And expect. Interesting. Okay. To obtain user input and then print the result as output, we need to bring the IO input-output library into scope. The IO library comes from the standard library known as std, so that's why we include it. By default, Rust has a set of items defined in the standard library that it brings into the scope of every program. You have to bring that type into scope explicitly with a use statement. Once again, very similar to C#, but I imagine it's better. Using the stdio library provides you with a number of useful features, including the ability to accept user input. As you also learned in Chapter 1, printline is a macro. This code is printing a prompt stating what the game is and requesting input from the user. It will be really interesting to see how you color your std out. Which is never mentioned, by the way, that this is the thing that you do for std out. I think it should be. Storing values with variables. Next, we'll create a variable to store the user input. It's doing it in the way that programmers of other languages expect it to work, creating a mutable variable that we then change. But once again, I have a feeling that's not how you really do it. Starting from what you're used to and then changing it to what it's supposed to be. Now the program is getting interesting. There's a lot going on in this little line. We use the let statement to create the do we? No, it's not there. Oh, I guess that's the other thing that we... Well, okay. There's a lot going on in this little line. We use the let statement to create the variable. Here's another example. Oh, that's an example. Fucking stupid me. Yeah. This line creates a new variable named apples and binds it to the value 5. In Rust, variables are immutable by default. And that is just... that's so tasty. Meaning once we give the variable a value, the value won't change. I love that. We'll be discussing this concept in detail in the variables and mutability section in Chapter 3. To make a variable mutable, we add mute before the variable name. The syntax starts a comment that continues until the end of the line. Rust ignores everything in comments. We'll discuss comments in more detail in Chapter 3. This is pretty cool. Like, this is like readable for an absolute beginner, which is surprising. But once again, I think it well, I don't think it has been explicitly stated that they expect you to know what programming is. They still re-explain some stuff though. They're like very lenient and not as gatekeepy as I almost wanted it to be. Returning to the guessing game program, you know what? You know that let mute guess will introduce a mutable variable named guess. That's what I guessed. The equal sign tells Rust we want to bind something to the variable now. On the right side of the equal sign is the value that guess is bound to, which is the result of the string of calling string new, a function that returns a new instance of a string. String is a string type, Jesus, provided by the standard library that is a growable UTF-8 encoded bit of text. The syntax in the new line indicates that new is an associated function of the string type. An associated function is a function that's implemented on a type. In this case, string. This new function creates a new empty string. That's what I also guessed. It's kind of like string empty in C#. You'll find a new function on many types because it's a common name for a function that makes a new value of some kind. In full, the let mute guess string new line has created an immutable variable that is currently bound to a new empty instance of a string. Yeah, that's what I guessed. But unsurprisingly enough, it doesn't go into like a real depth of what's happening behind every single thing, because we're gonna get to it actually. Receiving user input. Recall that we included in the input-output functionality from the standard library with the use stdio on the first line of the program. Now we'll code the stdin function from the IO module, which will allow us to handle user input. If we hadn't imported the IO library with use stdio at the beginning of the program, we could still use the function by writing the function call as stdio stdin, which is really nice. The stdin function returns an instance of stdio stdin, the type, which is a type that represents a handle to the standard input for your terminal. I see. Next, the line readline mute guess calls the readline method on the standard input handle to get input from the user. We're also passing the let mute guess at the argument to readline to tell it what string to store the user input in. Now, what I imagine we'll be doing later is instantiating the variable inside of there rather than separately. So we don't have to create it first as empty and then change it, and we can make it immutable. That's what I imagine. The full job of readline is to take whatever the user types into standard input and append that into a string without overriding its contents. That's interesting to know. So we therefore pass that string as an argument. The string argument needs to be mutable so the method can change the string's content. Or maybe that is exactly how you do it, which is like, alright. The indicates that this argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy that data into memory multiple times. References are a complex feature, and one of Rust's major advantages is how safe and easy it is to use references. You don't need to know a lot of those details to finish this program. For now, all you need to know is that, like variables, references are immutable by default. Really? Oh wow, that's so nice. Hence, you need to write mute guess rather than guess to make it mutable. Now, I want to look at clean input box, and it probably has something static. No, it doesn't. Let's go to registers. Oh yeah, I do use orange for static, so that means that using orange for mute also makes sense. I'll recolor types with yellow for base types. Was just some things being default so nice. I know, right? Exactly. I love, like, it's the fact that I can trust it. It's so good. Handling potential failure with result. We're still working on this line of code. We're now discussing a third line of text, but note that it's still part of a single logical line of code. The next part is this method, expect failed to read line. We could have written this code as IO is to the in read line and the same thing basically. However, one long line is difficult to read and it's best to divide it. It's often wise to introduce a new line, another white space to help break up the long lines when you call a method with the method name syntax. Now, let's discuss what this line does. As mentioned earlier, readLine puts whatever the user enters into the string we pass to it, but it also returns a result value. This string making me want to learn Rust. That's the idea. Good. I feel like Mud, you're the perfect person to learn Rust. I feel like you'll become that, like, you'll become even more powerful than you are right now. The things that you're doing in HK V1, let's not forget, god damn, if you use Rust, you will be unstoppable. And if I ever make a tech company, I will beg for you to work for me because you are incredible. Result is an enumeration, often called an enum, which is a type that can be in one of multiple possible states. We call each possible state a variant. Yeah, because you are already like, god damn. And having an actually good language, that is just straight up crazy. Chapter 6 will cover enums in more detail. The purpose of these result types is to encode error handling information. Results variants are OK and The OK variant indicates the operation was successful, and inside OK is the successfully generated value. The variant means the operation failed, and the contains information about how or why the operation failed. Values of the result type like values of any type have methods defined on them. An instance of result has an expect method that you can call. So we get a result returned right here, and the type of result has a method expect. This is explained really well, by the way. And that you can call. If this instance of result is an error value, expect will cause the program to crash and display the message that you passed as an argument to expect. I wonder if I press Ctrl C while that program is running and expecting my input, will that work? If that's the case, holy shit. the number of bytes in the user's input. If I remember correctly, we don't store it, and that's why, yeah, okay. So essentially the length, kinda. I remember that there are some directives in Rust that basically force you to handle every single thing, which sounds very exhausting, but exciting for the same reason. And such a good compilation message. Warning, unused result that must be used. This result may be an error variant, which should be handled. Unused must use. I want to basically turn that into an error. Rust warns that you haven't used the result value returned from read line, indicating that the program hasn't handled a possible error. I also like the syntax of it, because in C#, it feels quite a bit annoying trying to get std in and make it safe too. While in here, it's both easy and reasonable. The right way to suppress the warning is to actually write error handling code. Yeah, but in our case, we just want to crash this program when a problem occurs, so we can use expect. So if you expect it to just kill itself, then you use expect. But otherwise, you should really just handle the error. You'll learn about recovering from errors in chapter 9. Did I get banned for it? I hope not. Printing values with print line placeholders. Aside from the closing curly bracket, there's only one more line to discuss in the code so far. Oh, it's not... Huh. Strings are not raw by default. Well, that's new. This line prints the string that now contains the user input. The set of curly brackets is a placeholder. Think of as a little crab pincers that hold the value in place. Aww, that's adorable. When printing the value of a variable, the variable name can go inside the curly brackets. So basically, Rust strings are F strings by default. That's interesting. When printing the result of evaluating an expression, place empty curly brackets in the format string. Oh. No. No. Oh wait, I was thinking of something else. I thought that this string evaluated into here. But no, like you pass it here and yeah. Okay. I got both excited and scared. Place empty curly brackets in the format string, then follow the format string with a comma-separated list of expressions to print in each empty curly bracket placeholder 4 words. In the same order, printing a variable and the result of an expression in one call to print line would look like this. Okay, very similar to the format function in AutoHotkey. I'm pretty sure now double quote strings tend to be F strings in a lot of languages. Really? Single quote is more literal. True, in Fish, for example, that's the case, and overall in Fish, in Shell. But usually, if you want to use F strings, you need to do so explicitly. Like in Python, you put an F before the string. In C# you put an @ symbol before the string. No, that's for raw. In C# you use backticks, and then it's an F string. So having that default is interesting. I guess we'll learn later how to undo it. Generating a secret number. Next, we need to generate a secret number that the user will try to guess. The secret number should be different every time, so the game is fun to play more than once. We'll use a random number between 1 and 100, so the game isn't too difficult. That's so adorable. The book is so cute. Yet again, just simple default things being nice. Well, maybe I should argue against that. Yeah, generally, I want to easily expect my string to just be text. But that's probably because I'm so used to auto hotkey and it's not having interpolation. So I'm used to not using it. But maybe that's just how it is right now. And once I get used to it, it will be actually nice. Who knows? I guess I will in the future. We'll use a random number between 1 and 100, so yeah. Rust doesn't yet include random number functionality in standard library. That's interesting. Why? However, the Rust team does provide a rand crate with set functionality. So the Rust team, meaning that it's a, like, it's by the language creators rather than a separate library. Using a crate to get more functionality. Remember that a crate is a collection of Rust source code files. The project we've been building is a binary crate, which is an executable. The rand crate is a library crate, which contains code that is intended to be used in other programs and can't be executed on its own. Cargo's coordination of external crates is where Cargo really shines. Before we can write code that uses rand, we need to modify the Cargo toml file to include the rand crate as a dependency. Open that file now and add the following line to the bottom beneath the dependencies section header that Cargo created for you. Be sure to specify rand exactly as we have here with this version number, or the code example in this tutorial may not work. Pretty cool, like being specific to versions works a bit better, I feel like. Yeah, in the Cargo toml file, everything that follows a header is part of that section and it continues until another section starts. Yeah, I now know this because I was configuring the Starship prompt and it uses toml as well. In dependencies, you tell Cargo which external crates your project depends on and which versions of those crates you require. In this case, we specify the rand crate with the semantic version specifier 085. Cargo understands semantic versioning, sometimes called semver, which is a standard for writing version numbers. The specifier 085 is actually shorthand for starting from the start, 085, which means any version that is at least That's cool. Oh wow. Cargo considers these versions to have public APIs compatible with version 085 And this specification ensures you'll get the latest patch release that will still compile with the code in this chapter. Any version 0.90 or greater is not guaranteed to have the same API as what the following examples use. The course that I'm going through, rather, to learn C# does not have this shit. It just expects you pretty much to be using the same version as them, even if you're not, because a lot of time has passed. And the book actually explicitly says that we expect you to use this, so keep that in mind. That is so nice. Now, without changing any of the code, let's build the project as shown in listing 2.2. You may see different version numbers, but they will all be compatible with the code, thanks to Semver, and different lines depending on the operating system, and the lines may be in different order. When we include an external dependency, Cargo fetches the latest versions of everything that dependency needs from the registry. Which is a copy of data from Crates.io. Crates.io is where people in the Rust ecosystem post their open source Rust projects for others to use. After updating the registry, Cargo checks the dependencies section and downloads any crates listed that aren't already downloaded. In this case, although we only listed rand as a dependency, Cargo also grabbed other crates that rand depends on to work. After downloading the crates, Rust compiles them and then compiles the project with the dependencies available. If you immediately run cargo build again without making any changes, you won't get any output aside from the finished line. Cargo knows it has already downloaded and compiled the dependencies, and you haven't changed anything about them in your cargo toml file. Cargo also knows that you haven't changed anything about your code, so it doesn't recompile that either. With nothing to do, it simply exits. That is so nice, because I'm pretty sure in C# it would redo everything. And let's actually check out if I'm lying. Let's go to Welde. And inside of it, to Welde again, because I'm bad at naming. So let's .NET build. Well, technically, it didn't like build everything because it understood that, oh, actually, everything is built, right? But I guess it's just so slow that I thought that it didn't recognize it. Let's cargo build. But cargo build, once it understands that nothing has changed, is way faster than what C# gives us. So that's the nice thing. God damn. If you open the source main rs file, make a trivial change and then save it and build again, you'll only see 2 lines of output. These lines show that Cargo only updates the build, with your tiny change to your dependencies haven't changed, so Cargo knows it can reuse what it has already downloaded and compile for those. Wow, that's so nice. These lines show that Cargo only updates, yeah. Kind of wish it would actually go there. Okay, so I can actually use this as a link that I can save and go to Regel and then do this. So now the next time I go back to read, I can just run this link and it'll be exactly there. my voice is tired and my throat is on fire. Oh wow, that rhymed accidentally. So I'm gonna be ending stream, and holy shit, I've been reading docs for 3 hours, and for some reason it has been fun as fuck, and like overall very interesting and pretty easy to do. If my voice wasn't as tired, I would go on for longer, and I'm probably hungry, or at least should be hungry. So thank you so much everyone for watching. I hope this motivates you to learn Rust as well, and I might actually stream more today if I realize that my voice has calmed down, but maybe tomorrow or some other day. Thank you for watching everyone, and goodbye!